Okay, so good afternoon. So my name is Jinanjia Yu, and I'm an assistant professor in chemical engineering. I'm also a research scientist at the PwC. Yeah. So this is my 15th year at PwC. So what I'm going to talk about is the water treatment, especially the produced water treatment. So the previous speaker has talked a lot about, the transition of the energy, especially the use of green energy or renewable energy. But actually, so no matter what kind of energy we are going to use, so we need water, yeah. We need water, especially when we talk about the, green hydrogen. So actually the water for green hydrogen production is ultra pure water. So that means the total dissolved solid actually in the water for green hydrogen production, it should be less than 0.02 milligram per liter. So that is almost 1,000 times more clean than the tap water we are using every day. So it's very similar, for the solar panel. Yeah, when we use the solar energy, so we need the semiconductor. So when we are manufacturing the semiconductor, we also need ultra pure water. Okay, so we need water. We need water, but the problem is we are in New Mexico, so we don't have a lot of water. Yeah. So Alex just mentioned the water shortage globally. Yeah. If we look at the state, so basically we are a drought state. Yeah. So we have 1.1 million people. So actually they don't have enough clean water. Yeah. And right now, so we have 87% of water, so from groundwater. Yeah. And so because of the water level decline, yeah. So we need to find some new water resource. At the other side, so we produce a lot of produced water, yeah. So we have the second largest oil production in the state, and we produce a lot of water, yeah. So for example, in 2021, so the state produced 60 billion gallons of produced water per year. So that is almost 160 million gallons per day. It's equal to the total daily municipal water consumption in the whole state, yeah. One side, we need water. And the other side, we have a lot of produced water to be treated here. And in all this water, 90% of the produced water is currently reinjected for disposal, yeah, for disposal. And depending on the distance between the water production site and the disposal facility, so the cost actually changes between $2 per barrel to even $5 per barrel, yeah. So the cost of the water management, so actually is affected the proficiency of some small operators in the scale as well, yeah. So actually, to make this produced water as a usable water resource, so we are trying to do some produced water reuse or produced water recycling. But the issue is produced water is very difficult to be reused or to be cleaned, yeah. The biggest reason is if you look at the total dissolved solid, in the produced water, so actually, it's more than 200,000 milligram per liter. Yeah, especially if you look at the produced water in the Permian Basin. Yeah, so most of the produced water has a 150,000 milligram per liter TDS. So that's about 6 times higher than the seawater. And besides that, because the water, come out with the oil and gas, so there are a lot of organics. Yeah, there are a lot of organics and some bacteria. The sulfate reducing bacteria, the iron reducing bacteria. So all these kind of contaminant, make the produced water very challenging to be treated. Yeah. So right now, most of the commercially available technology, is based on brackish water. So that is less than 10,000 milligram or seawater. If we look at the desalination technologies globally, yeah, so it's very interesting. Okay, so if you look at the timeline, okay, so the membrane, actually, the membrane-based technologies or the membrane-based desalination technologies takes more than 50% of the overall water treatment or water desalination technologies, yeah. So what PwC do, yeah, so what I'm doing at PwC, actually, yeah, so we are trying to develop, some kind of innovative membranes to do the selective separation or specific separation of contaminants from produced water. And we are trying to use the produced water for beneficial purpose, yeah. So here is the history, okay, of the water treatment, produced water treatment at the PWRC, yeah. So we have been working on produced water treatment for more than 2 decades, yeah. So actually, 20 years ago, actually, so what PLC is doing is we are using the reverse osmosis, yeah. So right now, reverse osmosis is the most typical desalination technologies for seawater desalination, yeah. So the process is we use the pressure, okay, we use a high pressure to push the water through a membrane, and we can get the clean water. But the problem is the reverse osmosis is effective to treat the water with a relatively low salinity. So when the salinity gets very high, the pressure that is required for the reverse osmosis will be super high. Yeah? And the high TDS in the water can also result in the the membrane problem. Yeah. So actually, what we learned is the reverse osmosis works, but actually it's not the best. So we moved to the the thermal process. Yeah. So actually, Dr. Bausch was the PI for a couple of DOE projects to working on the humidification and the dehumidification process. So we are trying to use the wind, okay, the high wind conditions of the state and also the low humidity conditions to humidify the produced water. And we can recover the high clean water in terms of the dehumidified water vapor. So by that process, so we can treat actually more than 100,000 milligram per liters of the produced water. Yeah. And since 15 years ago, actually, we are start working on membrane-based process. Yeah. So we have developed different kind of membranes so we can remove, yeah. So we can remove the organics, different kind of bacteria, and also so we can desalinate, the more than 150,000 milligram per liters produced water and to achieve a zero liquid discharge. So that means when we do the produced water treatment, so we get the clean water and also, we get all the salt, yeah. So we don't need to do any kind of water disposal, yeah. So in this process, so we're also working on some kind of value-added resource recovery, such as the rare earth elements and also the lithium. So these slides, okay, so shows some prototype. So we have developed at the PWRC. So this work actually has been funded by different agencies. So here is the membrane, actually. Here is the membrane. So we fabricated in our lab at PWRC, yeah. If you look at this lab, if you look at this membrane, so actually it has a hollow structure, yeah. So what do we do? So we can control, yeah. So we can control the property of this membrane and we can control the pore size on the surface of this membrane. So determine by what kind of beneficial purpose we are looking for. So we can formulate and we can make different membrane for different application. So for example, so here is the large scale. So we created at the PWRC. So for this module, actually, it has a 2 inches diameter by 4 feet in length. And each module has a membrane surface area of about 16 square meter. And based on the membrane and also the membrane module, so we have been working with a manufacturing company located in Farmington, Pasco. So we have made different filtration unit. So for example, so this one has been made, to remove some kind of trace metal and heavy metal from the groundwater for the level halation, yeah. Because the level halation groundwater has a lot of contaminations due to the uranium, arsenic, like that. So we are trying to use this membrane-based process to remove, all that kind of heavy metals, from the groundwater. And this one is a thermal-based membrane distillation process, yeah. So when we talk about distillation, we put temperature in, we heat the water, and we collect the vapor. But when we add the membrane to the distillation process, so we don't need to make the membrane boiling. So at a super low temperature, okay, relatively low temperature, so let's say 100 to 150 degrees Fahrenheit, so we can recover the water in forms of vapor, yeah. Because the water is recovered in forms of vapor, so the water has a super high purity, yeah. So we have confirmed, the water we recovered from produced water actually is much more cleaner compared to the tap water. Yeah, it's more than 100 times cleaner compared to the tap water. So this unit has been designed, to do the produced water treatment in the San Juan Basin. And this one is designed actually for Clovis. So in the Clovis, we have a lot of dairy industry. Yeah. So they produce a lot of wastewater due to the contamination of phosphorus and nitrate. So what we did is actually we developed a specific nanofiltration membrane. So so we can remove the phosphorus and the nitrate by like 0.7%. Yeah. And this trailer can process 20,000 gallons per day of the wastewater. Yeah. If you look at this whole process, yeah. So the process is very easy to scalable. Yeah. So this is the module. This is the membrane module. So determined by how much water we have, what kind of capacity we are looking for. So what we need to do is we just change the number of these modules. So we can make this process portable, scalable, and highly efficient. Yeah, and highly efficient. Yeah. And just 5 months ago, actually, we just received funding from the Department of Energy. So what we are trying to do is, so we are going to collaborate with the New Mexico State University, the New Mexico Produced Water Research Consortium, and the Sandia, Los Alamos. We are trying to develop a membrane-based adsorption and lithium extraction process. So we are trying to achieve simultaneous high purity water recovery and high purity lithium recovery in terms of lithium carbonate. Yeah, so that's what we are doing in PWC right now. Okay, so I will hand it to Purifying. Thank you.
Thanks, Jinanjia.